Here we're going to look at example 2 and graph a system of equations with infinitely many solutions or no solution. In part A, we have two equations. We have 15x plus 5y equals 25, and we also have y equals 5 minus 3x. Now, the y equals 5 minus 3x isn't a form that we can plug this right into our graphing calculator. So if we go to y equals, we could type in 5 minus 3x with no problem. And we'd be able to find the coordinate points, we'd be able to plot them, and we wouldn't have much issue. So let's just quickly plot those points so we can see what this looks like. I'm going to go to my graph first so I have an idea, and then we'll go to our table. So it's negative 6. None of these points really work until we get to 0, 5. So let's start with that. So 0, 5, 2, negative 1. I'm actually going to use 1, 2 as well. 2, negative 1, 3, negative 4, and 4, 7. So 3, negative 4, and 4, negative 7 is off my graph, so I can't use that. So let's play our favorite game, connect the dots here, and we have our y2 value. So the y equals 5 minus 3x. Now if we look at the first equation, this 15x plus 5y equals 25, we run into a problem because this is not in a form that we can type into the graphing calculator. So if we are going to use the graphing calculators, it does have its limitations. We do need to have y isolated. The good news is we already know how to do this. We know how to isolate variables. So what we're going to look for is we want to isolate this y, and to do that, we're going to have to remove the 15x and the 5 from the left side. So to start that process, let's start by subtracting 15x from each side. We have 5y. Now these are unlike terms, so we'll just write them next to each other. We're not actually going to do 25 minus 15 and get 10x. That does not work. We cannot do that. And then we would divide each individual term by 5. So we get y equals 5 minus 3x. Now what you might notice is that we have the same equation, right? These two here are identical. So if I was to go to y1, or if I was just to think and use my brain a little bit, if I graph this, these two are going to be exactly the same. You're going to see the red line and the blue line overlap. So if I were to graph this, let's say we just drew a blue line right over the top of this. In terms of solutions, our solutions are when lines intersect, right? If we think back to the previous example, it's where the two lines crossed, we found the coordinate points, and those are x and y values. Now, since these lines are exactly the same and they overlap at every single point, what's going to happen is that we can state that there are infinitely many solutions. It's the same line, so they overlap the entire time. Every single point along that graph is a solution, and there are an infinite amount of points on a line. So if you do get the same equation, you'll see that. They won't always look identical. Sometimes you'll have something where maybe it's a larger version, or a multiplied by 2, everything's multiplied by 3. So you won't always realize it right away. Like we didn't see that until we isolated the y in the second or the first equation. But sometimes you'll notice it right away. Other times you will have to do a little bit of work to figure that out. So let's look now at part B, and let's start with our first equation. And if you're doing some thinking here, you can probably guess that if part A had infinitely many solutions, part B probably has no solution. That would just be a good guess here. I'm just going to close this out for a second because the calculator is not cooperating. Sometimes it doesn't allow me to use y1, unfortunately. All right, so we'll just use y2 and y3. So we're going to go green and red here. So my first equation, y minus 2x equals 6. Notice that y is not isolated, so we do need to do that. Fortunately for us, it's just one step. So that y is equal to 6 plus 2x. So I'll type that in. Just do my 6 plus 2x. Remember, you can plot these by hand using the slope and the y-intercept, but if you don't trust yourself or you just want to use a graphing calculator, you can do it this way. So I'm going to go to my table. I see that I have negative 6, negative 6, so I can plot that. That'll be way down here. Go negative 4, negative 2, That would be right here, negative 2, 2. Again, you don't have to use the exact same points I'm using. We just need enough points that we can plot our line, and 0, 6. So let's connect all those, and we have our line. All right, equation 2, I'm going to use green here, so I'm going to say I have negative 4x, apologize for that, plus 2y equals 8. And what we want to do is isolate y, so to do that, it's a lot like part A. We're going to add 4x though this time. So get 2y is equal to 8 plus 4x, and we'll divide everything by 2. So y would be equal to 4 plus 2x. All right, so we'll plot this. I'm going to go back to my y equals. Oh, they're letting me use y1 now. How nice of them. I'm going to go to actually y5 because it's green, and we're just going to color code here. Make our lives a little bit easier. I'm going to change the green I'm using though. So y equals 4 plus 2x. So we do 4 plus 2x. Again, I'm just color coding this. You don't have to enter it as y5. And if we graph it, we get something that looks like that. Now notice that these lines do not intersect. So let's go to our table. Let's pull some points. And let's get to plotting negative 4, negative 4. So it's going to be right here. Negative 2, 0. 0, 4. And we have our line. So I'm going to plot these. I'm going to draw these. It's a pretty bad line. Let's redo that. And it's a little better, but not by much. Now that's why. Use a little marker there. All right, there we go. That's worst case scenario. I have some technical difficulties here, but bear with me. I'm not going to restart this video because I don't want to start this all over again. There we go. All right, so what we notice, these two lines never intersect. The way we can tell that is if you go here, we have a slope of 2, and here we have a slope of 2. These two lines have exactly the same slope. They have different y-intercepts. So if you do remember from a geometry course or with parallel lines, these lines will never actually intersect. Since these lines will not intersect, that is when we have no solution. Our solutions are their intersection points. If lines don't intersect, we don't have solutions. So when you're graphing these lines, sometimes you will notice that there's infinitely many or no solutions before you even graph that, if you're kind of in tune or pick up on the slope of these lines. But you do want to be careful. Don't jump to conclusions too quickly. Sometimes just type it into the graphing calculator and just confirm what you already know. All right, that's it for this video, along with those technical difficulties, but we figured it out in the end, and all is well.